Uh, Good morning, everyone. In today's class, we'll discuss about the equilibrium concentration of the Frenkel defect. Right. In the previous two classes, we had a mathematical expression. Right. We have discussed mathematical expression of the equilibrium concentration of Schottky defect in ionic crystal and also in the metals, right? So in today's class, we'll discuss about the equilibrium concentration of Frenkel defect. See, before going to the equilibrium concentration of Frenkel defect, we need to understand what is actually the meaning of Frenkel defect. So Frenkel defect is nothing but the defect which is caused due to the interstitial atoms and vacancies. So this Frenkel defect will come under the category of point defect, one of the point defect. So we already discussed that point defects are zero dimension defects, and in the point defects we are having various subclassifications. So the first one, what we discussed in the previous classes, is the substitutional defect. The second one is the interstitial defect. Third one is vacancy, and the fourth one is the electronic defect. So the Schottky and Frenkel defect come under the category of the electronic defects. So Frenkel defect is actually defined as the combination of the interstitial atoms plus the vacancies which will be created by application of some amount of pressure or the force. It will be in the form of the low temperature also, and so on. So we just now we'll just discuss about the equilibrium concentration of Frenkel defect. Right, with this idea, we'll move forward to the last topic of the unit 1, that is chapter 2, equilibrium concentration of Frenkel defect. Right. So here we just had, now see everybody, now we had an information that we only know that what is actually the meaning of Frenkel defect, right? So here we need to derive the expression from the definition what actually we know. So for that, we have to consider the ideal crystal, what we have considered in the previous derivations, right? In the same manner, we'll move to the next one. So we just can see we already considered the ideal crystal. Let us consider the ideal crystal and EF. See, E suffix F, energy required to create a Frenkel defect. I think that you will not have any problem, as we have done in the previous two derivations in the same manner, right? So E suffix F, small f, is energy required to create a Frenkel defect. And you already know that since you are considering the ideal crystal, so the number of atoms is considered to be capital N, and the N suffix I, as I told you, that the Frenkel defect is a combination of interstitial and vacancy. So interstitial atoms, so we need to know how many interstitial atoms will be there inside this crystal, ideal crystal, uh, which is a defective, right? And that defective crystal is due to this interstitial atoms and vacancies which has been created, right? So n suffix I is the number of interstitial atoms, and what we have to calculate, concentration of Frenkel defect. So let small n be the concentration of Frenkel defect. So this should be very much clear to everybody that since you are considering the ideal crystal, EF is the energy required to create a Frenkel defect. Capital N is the number of atoms, and N suffix I is the number of interstitial atoms, and small n is the concentration of the Frenkel defect. Clear, everybody? So with this, we need to go for the probability concept, that is P is equal to. So normally we have taken here in the previous cases in metals, we have just taken the probability concept, that is n factorial by small n factorial into capital N minus small n factorial. I think that this part everybody is having information regarding this particular term, right? And what is the extra term that will come in the Frenkel defect? N, see here, here it should be n suffix I. So n factorial into n suffix I minus n factorial, right? So by using this probability concept, what we'll do is, see, what we can write, since some disturbance has been created. So the disorderness in the system, we just say that it is called the disorderness in the system is entropy. So the disorderness increases with the increase in the entropy, which is given by S is equal to K log P. You can just see we had already the mathematical expression of the entropy. S is equal to K log P. So P is n factorial by n small n factorial capital N minus small n into n suffix I, right? This is missing here. So you just write n suffix I factorial n fact small n factorial into n suffix I minus n factorial, right? So we in the previous cases also see we discuss n is here number of atoms. So what we have to write in the numerator? Capital N factorial. So what is remaining? What is actually we are calculating? Small n. So concentration of Frenkel defect we have written in the n factorial term. So what will be definitely remaining? Capital N minus small n factorial. So it is clear, everybody. In the same manner, here also n suffix I factorial, n factorial into n suffix I minus n factorial. Right? Clear, everybody. Now the first part of this derivation, I think you'll have a very clear idea. See here what we need to do here. It should be n I. See, this is you should be very clear. So before proceeding further, so see n suffix I and factorial, n suffix I factorial minus n factorial, right? So clear, everybody. So with this, we move to the next one. The next slide. See. So here again, what we'll do, we just apply the uh, see, before going to this, we need to apply the Stirling operation approximation. So by approximation, Stirling approximation, what you can do, we already know log x. The Stirling approximation say that log x should be very clear to you. Log x factorial is equal to right, right, log x factorial is equal to x log x minus x, right? So this part we already know in the previous derivations also. So by using this Stirling approximation, we have to expand this factorial, whatever the term over here it may be. So we need to expand that term, that has come to be x log x minus x, right? So here, here the x may be. So you always remember here x may be, this x may be capital N, right? X may be, it should be very clear to everybody, right? Small n, right? And x may be capital N suffix I. So the x may be capital N. So here x may be capital N. You can see this x may be capital N. So this x may be capital N, x may be small n, and x may be capital N suffix I. So we have to just replace this instead of x, just we have to replace n. So here n log n minus n. Here x is equal to n, substitute that. So log n factorial is equal to small n log n minus small n. And log of n suffix I factorial is equal to ni n suffix I log of n suffix I minus ni suffix I. Right, with this, see, it is very clear to you. So now we'll just move forward to the next step, right? See, S is equal to K log P. Log p is we have just expanded. See, n log n minus n. Then log n factorial has been expanded. That minus is there. So minus n, minus of minus is plus here. Minus n log n plus n. So what is remaining? Then capital N minus small n. So minus of capital N minus small n log of capital N minus small n plus capital N minus small n. So we just expanded the terms which are there in the previous slide. So we just expanded that and we got the expansion term till here, right? The next one is what? Log n suffix I factorial. So how we'll write it? N suffix I log of n suffix I minus log of n suffix I, right? These we have just expanded with the what you can say Stelling operation, right? We just applied the Stelling operation, and in that Stelling approximation we have expanded the factorial term here. So here in the same case minus has been taken, so minus n log n minus going inside plus n. The same manner minus of n suffix I minus n log of capital N I n suffix I minus n plus n I minus n. See, if you want, I will just write it down here again. See, we just expanded here log n factorial, right? Clear, everybody? See, log n factorial n log log n minus n. Clear? Next, log of next term is, see, this is for your reference. So log of n factorial, which is equal to n log n minus n. So what is remaining here? Next one is log of capital N minus n. Close the bracket, factorial, which is equal to n minus small n log of n capital N minus small n, then minus n minus small n. So you if you just make it in bracket, minus n minus into minus plus. In the same manner, the expansion of this is you already know, log of n suffix I factorial. So what will write that? Expanded by Stirling approximation, n suffix I log of n suffix I minus n suffix I. So like this, in the same next case also, see, this is n actually. So in the next case also, we just expand this n suffix I. The next one also, what we'll do, just will for your reference, for your understanding. So here the next one, in the expression n suffix I minus n, this is factorial. So here n suffix I minus n log of n suffix I minus capital N suffix I minus small, right? So in this way we just expanded by using this value approximation, and wherever the negative sign and positive sign we just replaced here, and we got this particular expansion term. You see, here minus was already there, so when minus is there, so this term will, here this term will become positive. So in the same case, see, you can just see the expansion. So when you see the expansion, n log n minus n, as it is a log n factorial, we have written in the same manner. There was minus of log of n factorial. So minus n, so minus e, minus of this whole term, minus e. When it is minus, the minus of this whole term. So minus n log n, minus into minus plus n. Clear, everybody? Next one was see, log n minus capital N minus small n factorial. What we have written, minus is already there. See here, minus was there, right? You can just see the previous slide. You can just pause it and you can just see it. So you'll find that there is a minus here. So minus of n my capital N minus small n. See, log of n minus n, log of n minus. So minus into minus plus. So therefore it is capital N minus small. In the same case, there was a plus here. So here as it is plus log ni factorial. So we have just written ni log n I minus n I, right? So minus of log n, again the same. See, minus of log n is the factorial. So minus n log n plus n. In the same manner, log of n suffix I minus n factorial. So we just expanded here. Minus was already there. So we just replace this minus here. Minus n suffix I minus n log of n I minus n, minus into minus will be plus. We got this capital N minus n I minus n. So with this, I think that it is very much clear to you. See, now we just I think that you got a very clear idea. So now we just move to the next one, right? So now x n log n as it is. See, minus capital minus n. So here they we definitely, this and this term will cancel. I will just show you. See, so this should go. See, minus n. See, I will just start tell you. This get cancelled, right? See, this plus n, and here there will be minus n. This minus n plus n will get cancelled. So what is remaining? N log n, as it is remaining n log n. See, minus n plus n is getting cancelled. What is remaining here? Minus n log n. So minus n log n, right? So now here you can just see plus n minus n. This will get cancelled. See, this plus n and this minus n get cancelled. So here n minus c, capital N minus small n. So capital N minus small n log of capital N minus small n, as it is we have written. What is remaining? N suffix I log of ni minus c minus ni plus ni. You can see, if you want, I'll just do it, right? N suffix I, this and this will get cancelled. So here, so ni, right? Just see, ni ni minus n log of ni minus n, as it is, plus ni and minus ni get cancelled, plus n and minus n get cancelled. So what is remaining here? N log n as it is. See, if you want, I will just see this plus n and this minus n get cancelled. Clear? Plus ni, and where is minus ni? This will get cancelled. So now this when you just see this term as it is n log n, you just see n log n log n minus n log n minus n log n minus of capital N minus small n, right? Log of capital N minus small n. So minus of, see, minus of n minus small n log of capital N minus small n, as it is have written. So what is there here? Plus Ni, see, plus Ni log Ni, as it is have written. So what is remaining here? Minus n log n. See here, minus n log n, minus of, see, minus of n suffix I minus n log of capital N I minus n, as it is. So anything that you have not understood, so this is what we will do. See, next one. So by using the law of thermodynamics, the change in the entropy we have already done. So F is equal to U minus D internal energy minus the absolute temperature, combination product of absolute temperature and the entropy. So what what we have to do now, U is nothing but N into EF, we already done. In this is the internal energy mathematical form. So N into EF minus T. S, C, S you already know. This entire term is your S. So we just see n log n log n, minus n log n, minus n, minus of capital N minus small n, capital N minus small n, right? Log of capital N minus small n, as it is, plus n suffix I log of ni minus n log n, minus of ni minus n log of n suffix I minus n. So right, so with this I think that you are having a very clear idea. Right, we just clear all this. Right. Remove this. Okay, we can just see. So at equilibrium, the change in the, see, before this, so at equilibrium, what you can write, the change in the free energy is minimum. So what is the formula that we need to apply? Dou F by dou N is equal to 0. This is the common mathematical expression which say that the theoretically the value of at equilibrium, the change in the free energy is minimum. So you can just see. So if we just expanded this term, so dou F by dou N is equal to 0. So what will be there in the previous slide? You can see. So n in small n into EF. So differentiated dou F by dou small n. So with respect to n, this value will become EF minus n. So again, we have to take this small n log n. So small n log n, what we have to do? What we have to do? See, in the previous case also, we have just considered that. Here also, we are considering the same thing. See, so you already know, see, log of this part you already done, log of n and log n. Clear? So here n log n is, this is what here? U. This is, so u v. So differentiation of, u into v is your u v dash plus v u dash. Clear everybody? So u is n. So as it is n, I will write here. See, for first one I will do it log n. Log n is what? 1 by n, as it is I have written, plus as it is you write, right? So v is what? Log n. So I'm writing log n as it is. But, and again u dash is n. So this term will be 1. So this and this will get cancelled. What is remaining here? The differentiation of n log n is 1 plus log of n. So like this, you can just simplify it individually. See, you can just simplify it individually. See, one more I will show you. Capital N So you can just see this. This is we just differentiated d of u and v. So in the same manner, u v dash. See, in the same manner, we'll do this u, right, v dash plus u dash v, right? Clear, everybody, right? I think this you understood. So I'm just removing this. Here we'll just do this second differentiation, right? Now this is also, this is the value of small n log n. So this will just do it again, right? So what we'll do here, so we just differentiate this capital N minus small n log of capital N minus log of capital N minus n, which is equal to d of uv is equal to uv dash plus u dash v. So you can just see this. So we got this value. So you can just see n capital N minus n. Again, this is a differentiable. U is this. V dash is this. So with this, this is what we get. So again, differentiation of capital N minus small n will fetch you minus 1. Minus of, as it is, log of n minus n minus 1 will again, we have to do differentiation of capital N minus small n. So when you do the differentiation of capital N minus small n, with respect to small n, you'll get the value as minus 1 minus it. Same thing what we have done in the previous one. So here with this, what you can say that this part, when you just cancel it out, see, if you cancel it, you can see. So we'll just clear all these things, right? So here what we'll do is that see, okay, now what I'm trying to tell you that this small n and this small n get cancelled. Minus 1 is remaining, minus 1 minus of log n, as it is. See here, mine capital N minus small n, numerator and denominator get cancelled. So what is remaining here? Now itself we can just do minus 1 into minus 1, that is plus 1. Clear, everybody? Minus of log see, minus of log n cap minus small n minus 1 minus into minus, this is what, plus log of capital N minus small n, as it is I have written here. See here, this small n numerator and this small n denominator. What is remaining? Minus 1. So what we have written here? Minus 1 minus log n, as it is I have written, right? So what is, see here, minus into minus is plus. Okay, so this and this can cancel. Minus into minus is plus 1. Clear, everybody? See here, minus into minus is plus log of capital N suffix I minus n, as it is written, right? So with this, we just move to the next step. Clear, everybody? See, EF is equal to, see, EF will go to the left hand side. EF is equal to KT minus 1 minus 1. What will be there? Minus 1. See, minus 1 minus 1 minus 2 plus 1 plus 1 minus 2 plus 2. That can get cancelled. What is remaining here? That will definitely get cancelled, is equal to KT. So here, see what I've written, minus log n minus log n. You can see if you want again, with this, see, minus n minus log n minus log n, it will become minus 2 log n, right? Plus, as it is I have written, log of n minus n plus log of n suffix I minus n, as it is we have written. Any, I think that, see, very clear. See, minus 1 is there, minus 1 is there, minus 2, it will become minus 2. Or else you can just see minus 1 plus 1 get cancelled, minus 1 plus 1 get cancelled. Clear? Minus log n minus log n minus 2 log n, log of capital N minus small n plus log of n suffix I minus n. Clear everybody? Now EF, this will go to this side, kt is equal to, this is in the form of x log a. This can also be written as log the x log a square, right? Plus log of n minus n plus log of n minus n suffix I minus 1. So right, we'll move to the next one, right? See, ef by kt is equal to, see, now it is clear, right? See, uh, next one. The ef by kt is equal to log of capital N minus small n and suffix I minus n. So in the denominator, you'll find that n square will be there. Okay. Next one. So see, log will go to the left hand side. You already know exponential of ef by kt is equal to capital N minus small n and suffix I minus n by n square. So very simple. So you already know. See, if small n is very much small n is very less than capital N, and also small n is very less than capital N suffix I, so small n can be neglected. So this we can just neglect. So this value we are neglecting. So what is remaining? N into ni. See, n into ni. E to the power of ef by kt is equal to n into ni by n square. We want n only, right? So n square will go to this n capital N into capital N suffix I. So this will go to the numerator. When it goes to the numerator, see, it is denominator. It is in the denominator, right? You can see this is in the denominator. N square will go there. E to the power of ef by kt will be in the denominator. When it comes to the numerator, minus sign, it will come with the minus sign. So n square is equal to capital N into ni e to the power of minus ef by kt. So next, last step that we need to discuss here, small n is equal to under root of capital N into capital N suffix I e to the power of minus ef by kt. So with this, we'll come to the conclusion of the today's derivation. So with this, we have completed our chapter 2, unit 1. So in the next class, we'll just see the next unit, that is unit 2 and chapter 1, right? So, and before that, if it's possible, we just discuss the numericals, also more numericals, right? Thank you, everyone. Thank you for your patience.